Welcome, everyone. Today, we're diving into semiconductor manufacturing in Coimbatore, exploring the opportunities, knowledge base, and technical process roadmap that define this emerging hub. We'll look at local momentum, strategic initiatives, and the mastery of processes, from wafer fabrication to advanced packaging. This sets the stage for understanding how Coimbatore fits into India's broader semiconductor ambitions and what lies ahead for this dynamic sector. Let's take a quick look at our agenda. We'll start by understanding India's and Tamil Nadu's semiconductor landscape, then focus on Coimbatore's emerging role. We'll explore opportunities for the local ecosystem, the required knowledge and skills, and walk through the semiconductor manufacturing process. Finally, we'll wrap up with a roadmap and recommendations to guide future growth and collaboration. India's semiconductor ambition is clear, moving from design services toward manufacturing leadership. With a 76,000 crore outlay under the India Semiconductor Mission, over 10 projects approved for 2025 and 2026, and cumulative investment commitments reaching 1,60,000 crore, 6 states are actively developing semiconductor projects. This momentum includes fabs, OSAT facilities, and equipment manufacturing, signaling a strong national push. Tamil Nadu's Semiconductor Mission 2030 places Coimbatore at its core. With a 500 crore mission focusing on design, equipment manufacturing, R&D, workforce development, and ecosystem building, the state is creating dedicated semiconductor parks in Sulur and Palladam. The breakthrough by Yield Engineering Systems at Sulur, shipping India's first commercial semiconductor equipment to Taiwan, highlights this progress. Additionally, design promotion schemes aim to build a fabless ecosystem and skilled talent pool. Coimbatore is gaining real momentum. The YES facility in Sulur has shipped India's first semiconductor manufacturing equipment globally, sourcing over 100 local components. Operational since late 2024, it focuses on advanced packaging solutions. Looking ahead, plans include semiconductor equipment parks, expanding precision component supply chains, potential OSAT units, and skill development aligned with global standards, all pointing to a robust future pipeline. Why Coimbatore? The city offers strategic advantages essential for semiconductor growth. It boasts premier engineering institutions producing skilled talent, a precision manufacturing base with decades of expertise, and a strong industrial ecosystem supported by associations like CADICIA. Its location near Bangalore and Chennai provides excellent connectivity, while proactive government policies create a favorable environment for investment and expansion in semiconductor manufacturing. Opportunities in Coimbatore span several areas. Building on YES's success, local semiconductor equipment manufacturing can focus on subsystems and metrology tools, which are less resource-intensive than wafer fabs. Skill development programs targeting cleanroom protocols and equipment maintenance are vital. The precision component supply chain can leverage existing clusters, while ancillary industries like ultra-pure water systems and specialty gas handling offer entrepreneurial potential. OSAT and advanced packaging present accessible entry points, given local talent and industry strengths. Challenges and considerations are important to address. Full wafer fabs require massive capital and infrastructure, making initial focus on equipment and back-end processes more feasible. Water and environmental needs demand sustainable practices and robust treatment systems. The talent gap calls for specialized training beyond traditional curricula. Ecosystem maturity will take time, so starting with equipment and components is pragmatic. Competition from other states means Coimbatore must leverage its speed, supply chain, and engineering quality to stand out. The required knowledge base covers core technical competencies like semiconductor physics, materials science, cleanroom protocols, process engineering, vacuum technology, metrology, yield management, and equipment operation. For Coimbatore stakeholders, skills in precision machining, surface engineering, automation, quality management, supply chain development, clean room design, specialty chemicals handling, and data analytics are essential. Developing certificate programs with local institutions and partnering with global firms like YES will build this expertise effectively. Understanding the semiconductor manufacturing process is key. It begins with wafer preparation, involving silicon purification and wafer slicing. The front end forms transistors through oxidation, photolithography, etching, doping, and deposition. Back end of line builds interconnects with metal layers and planarization. Wafer testing identifies defects, followed by assembly and packaging steps like dicing and bonding. Finally, rigorous testing and quality assurance ensure reliable chips ready for shipment. Let's dive deeper into wafer preparation and front-end processing. Starting with high-purity silicon, single crystal ingots are grown and sliced into wafers polished to atomic flatness. Cleaning removes contaminants, then thermal oxidation grows precise oxide layers. Photolithography transfers circuit patterns using light exposure, a critical and costly step. Etching shapes transistor features, followed by doping to create electrical regions. Thin film deposition and chemical-mechanical polishing prepare layers for the next steps, all requiring extreme precision. The back-end-of-line process builds the multi-layer interconnect network. It starts with depositing dielectric layers to reduce capacitance, then patterning vias and trenches for connections. Barrier and seed layers prevent metal diffusion and enable copper electroplating, which fills these features. Chemical-mechanical planarization smooths surfaces for subsequent layers. This sequence repeats across many metal layers, culminating in passivation and bond pad formation, protecting the chip and enabling packaging connections. Assembly, packaging, and testing transform wafers into usable chips. Electrical probing sorts good dies from defective ones. The wafer is diced into individual dies, which are attached to substrates or lead frames. Interconnects form via wire bonding or flip chip methods. Encapsulation protects the die, with advanced packages using underfill and thermal materials. Final testing includes functional checks, burn-in to screen early failures, and quality inspections before marking and shipment, ensuring only reliable chips reach customers. Our roadmap and recommendations focus on collaboration and phased growth. Local industry should form supplier clusters, invest in precision machining, and partner with global equipment makers. Educational institutions can launch specialized programs and collaborate on labs and internships. Entrepreneurs should target high-value niches like specialty chemicals and automation, leveraging design promotion grants. Government must accelerate park development, offer targeted incentives, and support skill missions aligned with global standards. The phased approach starts with components and skills, then OSAT units, and eventually front-end fabs as the ecosystem matures. In conclusion, Coimbatore is well-positioned to contribute significantly to India's semiconductor journey. While not initially a leading-edge fab location, it offers a vital hub for equipment manufacturing, precision supply chains, OSAT, and talent development. The success of YES, supportive policies, strong local education, and manufacturing strengths create realistic, impactful opportunities. Collaboration among industry, academia, and government will be the key to turning this potential into lasting success. This presentation is based on authoritative sources, including Tamil Nadu's Semiconductor Mission 2030, updates from Yield Engineering Systems, the India Semiconductor Mission, and industry technical resources. Local industrial reports and various analyses on India's semiconductor push provide additional context. Please note this is for strategic discussion only. Investment decisions require detailed feasibility and current government guidance. For further information, feel free to reach out via the provided email address.